Today's topic: Peacefair AC DIN rail meter, product number PZEM-008. Well guys, we're going to have some background noise from the highway, but I need the door open here to actually shoot this video, so I've got plenty of light. As we started out with, we're going to be installing this DIN rail connector, or DIN rail meter, not a connector. It says A-torch on top of it. And the purpose of installing it is to monitor how much my solar panels are actually putting back into the system here. Now I know you're going to see a few things here, and I'm trying to hold this camera and shoot this video, so it might be a little shaky, so bear with me. In this hole, there should be, and there's not, this is a temporary hookup, you need some kind of a connector like you see right here. It screws into the box and actually protects the wires. But this is just for testing, and that is not the proper way. However, we're going to do it just for testing purposes. Now, they say in the instructions that you need two breakers, one before and one after. Well, I'm not sure I understand why, because I'm going to have a breaker right over here. You see right here, this 15 amp breaker that's going to be carrying that voltage over to that meter. Now I did put this breaker in line because I am going to be using the voltage over here to tie something else in. So I've got a double breaker basically in the system. Don't understand why they say breaker before, breaker afterwards. You guys that are watching this video that are savvy in this stuff, maybe put some comments down in the comment section below to help me understand why they want two breakers in there. To start out with, let's go down here. This conduit coming in is the wires from the solar panel. You see one here, and one back there. And how I have those hooked up is the green is the ground. It's going to the ground bar on this side over here, and it's tied in right back there. I'm not going to stick my fingers in there, but you can see the green wire tied back here to that bar right there. Now then, the other two wires, the red one is this one. It is running right there. So I'm getting 120 volts. Now the meter says 119, but it's 120. And then of course the white one that you see coming in over here, runs across here, comes up here, runs through the hole in the box, comes out here, runs down the center of this. There's a hole back here. It goes all the way through this, comes out at the bottom. You'll see it runs in there. Like I said, comes up here, goes in there, comes out here. It's running back up in here, and it's tied in to the neutral bar right there. That is what the meter is picking up on. That's what's telling it it's got 119 volts, 3.51 amps, 405 watts, and 1.32 kilowatt hours produced. Now, this wire here is also going to the neutral bar. It is going to the negative side of the breaker. This, again, is coming out here, going back over here to the breaker itself in the breaker box. So if I turn this down, it's going to turn it off. Right now it's currently on. It's got power coming out of these two little wires down here at the bottom, which in return runs through here and goes to the live and the neutral wire on the actual DIN rail meter to power it up. It's not that hard to hook up, but I'm still a little out of place on what they're saying about two breakers. In reality, I could do away with this breaker, being that I already have this breaker over here, and I should be able to run them direct without this breaker here. But I did follow the instructions to a certain point, and that's where I said enough is enough. I'll put that breaker in there because I needed a source of power over here for another application. The meter works, two solar panels. Now let me show you what panels I have hooked up to this, so you see what they're doing. All right guys, it's going to be a little hot. We're out here in the sun, and as you see here, I have got one Chinese microinverter, a WVC300, and I have another Chinese microinverter, a WVC 600. I've got them tied together, running into a junction box there. Then you see tube coming out, running all the way around there, up to my disconnect. Now let me get around the front. And while I remember, if you've gained any valuable information from this video, we ask real quickly that you go down there and hit the little green button on the right hand lower section of this video. Hit the subscribe, like button, post comments. We love seeing comments, positive or negative. We surely respond to all those comments, and it does help this channel. You just don't know how much. Whenever you post a comment down below, other people that interact and get involved, it helps our channel grow. We're a small channel. But yes, we ask please hit the like, subscribe button, and leave a comment or two. It really does help us. Now back to where we left off. You've got the wiring coming in here, and then set up protective sheeting. There's another little junction box. Then it runs up here to the disconnect. Now, if you don't have a disconnect with a pull handle that you can shut on and off, and it can be locked out, you're probably not going to pass inspection. I can tell you that I went through holy hell trying to get the permit for this and get the inspection satisfied by the power police, I call them. They are very, very picky and take their time. I want to throw a little bonus in this video. You see I've got another panel just standing up over here. Now that's a 295 watt panel, and then there's another 295 watt panel, and then a 305 watt panel. The 305 is Jinko's, the 295 is Trina Solar. I've got some other videos out there, some other testing I've done with these, and both of them are pretty good panels. They're averaging about 66 to 69% efficiency rating, which is pretty good for some panels that are about 5 years old. But let's jump back inside and see what they're reading now. Another added bonus to this thing is that you see the WVC 600. It is set up to run 2 solar panels. Now, that is BS. In one of my other videos, I'll explain in more details, but I just recently, just in the last hour and a half ago, you see there's both of them are plugged in. I ran that one over there to that stand-up solar panel, and it did generate 596 to 605 watts of electricity. However, it overheated within 30 minutes and shut the microinverter down. So if you're trying to run 295 watt solar panels on the 600 WVC 600 microinverter, it will not work effectively. It'll start out, it'll run good, it'll put you up there, you know, at about the 66 to 69 to 72% range, and then boom, it'll shut off because it overheats.